Let's begin now. Coordinates. We understood from graphs that a point on a plane can be specified by its coordinates. The x-coordinate is called the abscissa, and the y-coordinate is called the ordinate. These coordinates form an ordered pair with the x-coordinate always written first. For example, a point A with coordinates x equals to 2 and y equals to 3 is written as A, usually in uppercase, and the two coordinates written in a bracket separated by a comma, 2, 3. This is different from another point B with coordinates 3, 2. Distance between 2 points. Consider a point A with coordinates x1 and y1. And point B with coordinates x2 and y2. From the geometry of the figure and using Pythagoras theorem, we can find the distance between A and B. The distance AB is now equal to the square root of the sum of the squares x2 minus x1 and y2 minus y1. In general now, the distance between 2 points, A with coordinates x1 and y1 and B with coordinates x2 and y2 is given by AB equals to square root of x2 minus x1 all squared plus y2 minus y1 all squared. It does not matter which point is taken as x1 and y1 or x2 and y2. What matters is that the order in which they are taken must be consistent. Let's take an example now. Find the distance between the points 4, 6 and 1, 2. Let's take the points 1, 2 to be x1 and y1 and 4, 6 x2 and y2. And then applying the formula for the distance between 2 points, we have square root of 4 minus 1 all squared plus 6 minus 2 all squared. This simplifies to the square root of 25, and we have 5. The distance between the 2 points, therefore, is 5 units. Midpoint of 2 points. Consider a line drawn by joining 2 points A with coordinates x1, y1 and B x2, y2. If the midpoint M has coordinates xm and ym, then the length of AM is equal to BM. That is, xm minus x1 is equal to x2 minus xm. Solving for xm, xm is equal to half of x1 plus x2. Similarly, ym will be equal to half of y1 plus y2. In general, therefore, the midpoints of 2 points A, x1, y1 and B, x2, y2 is given by half of x1 plus x2, half of y1 plus y2. Let's do this example. Find the coordinates of the midpoint of the line joining 3, -4 and -1, 10. Remember that the coordinate of the midpoint is given by half of the sum of the x coordinates and half of the sum of the y coordinates. Interpreting this, we have 3 plus -1/2, -4 plus 10/2. This simplifies to 2/2, 6/2. The coordinates of the midpoint, therefore, is 1, 3. Equation of a straight line. Given a straight line that cuts the x-axis at a point C, if we consider another point on the line with coordinates x and y, the gradient m of the line is given by y minus c divided by x. Multiplying both sides by x, we have mx equals to y minus c. Making y the subject of this equation, it becomes y equals to mx plus c. This is the general form of the equation of a straight line, where m is the gradient and c is the y-intercept, that is, the point where the line cuts the y-axis. It has the coordinates 0, c. Let's call this general form of writing the equation of a line the gradient and y-intercept form. Any equation of a line can be rewritten in this form. Next, we can derive the equation of a line when given the gradient m and one point x1, y1. If we draw a straight line, where x1, y1 is a point on the line, let a point P, x, y be any other point on the line. Then the gradient m will be y minus y1 divided by x minus x1. If we cross multiply, we have y minus y1 equals to m into bracket x minus x1. In general, the equation of a line that passes through the point x1, y1 and has gradient m is given by y minus y1 equals to m into bracket x minus x1. We may call this form of writing the equation of a line the point slope form. Thirdly, we can derive the equation of a line when given 2 points, x1, y1 and x2, y2. If we draw a straight line on the xy plane, and we know 2 points, x1, y1 and x2, y2. Let a point be x, y on the line. We know normally that the line has a gradient of y2 minus y1 over x2 minus x1. This gradient is also equal to y minus y1 over x minus x1. The two gradients are equal since the points lie on the same straight line. That is, the points are collinear. Thus, y2 minus y1 over x2 minus x1 is equal to y minus y1 over x minus x1. Rearranging this equation with the aim of having y values on one side and x values on the other side, it becomes y minus y1 over y2 minus y1 equals to x minus x1 over x2 minus x1. In summary now, we have discovered that the equation of the line can be derived in three forms, depending on the variables we are given. The slope-intercept form is y equals to mx plus c. The point slope form is y minus y1 equals to m into bracket x minus x1. And the 2-point form, y minus y1 over y2 minus y1 equals to x minus x1 over x2 minus x1. Now only the first two, the slope-intercept and the point slope form, need to be remembered. This is because the 2-point form is essentially the point slope form. Let's take an example. Find the equation of the line through the points minus 2, 1 and minus 1 over 2, 4. Let the points x1, y1 be minus 2, 1 and x2, y2 minus 1 over 2, 4. The equation of the line using the 2-point form is now given as y minus 1 over 4 minus 1 equals to x minus minus 2 divided by minus 1 over 2 minus minus 2. Simplifying this, we have y minus 1 over 3 equals to x plus 2 divided by 3 over 2. This further simplifies to y minus 1 equals to 2 into bracket x plus 2. And after opening brackets and collecting like terms, the equation of the line can be written as y minus 2x equals to 5. Now, as earlier mentioned, in case you can't exactly recall the 2-point form formula, you can find the gradient of the 2 points and then use the point slope formula, which is less cumbersome. The gradient of the 2 points is 2. Using this gradient with any one of the 2 points will give us the same equation.